For a little over 100 years, humanity has reached for the skies. The Wright brothers' lift brought us to commercial flight, which later paved the way to several trips to the moon. These strenuous voyages brought rise to the International Space Station. Today we dream of the next step, interplanetary expansion. For years, Mars has been seen as prime real estate for humanity. Dried up riverbeds, frozen ice at its poles, along with fertile soil and a rich carbon dioxide atmosphere, make it our best bet for sustained habitation. Between 71 and 96, the Soviet Union attempted sending 10 rovers. In 1976, however, NASA's Viking 1 and 2 changed the paradigm entirely, being the first orbiters to return over 50,000 photos. Since, NASA's Pathfinder, Spirit, Opportunity, Phoenix, Curiosity, Insight, and Perseverance have touched Mars' surface to deliver the crucial information that have fueled the quest for the second planet. But what are the benefits of exploring Mars? For one, understanding Mars and its potential life forms can help us better understand planetary formation and evolution, along with climate and water abundance. The red giant offers a comparative model for studying atmospheric processes that could apply to Earth. Rovers will only get us so far. Human exploration will facilitate data collection and on-site analysis. Furthermore, humans can assist in repair and maintenance to prolong the rover's life and open us up to more complex tasks like deep drilling for water. The numerous benefits, however, come at the expense of astronauts' health, along with substantial resources. Before getting humans to Mars, we need to get them prepared. Mars offers extreme and unique physical challenges primarily due to low gravity and radiation. Mars has about 38% of Earth's gravity, and with virtually no strain on the human body, muscle atrophy and decreasing bone density are inevitable. The thin atmosphere and lack of magnetic field expose explorers to intense cosmic radiation, increasing the risks of cancer, DNA damage, and other radiation-induced illnesses. Together, these conditions require careful medical planning and technological innovation to support long-term human health on Mars. Still, psychological challenges may even rival the physical. Consider the mental state of the world during the lockdowns. Over the pandemic, anxiety and depression saw a 25% increase globally, and for many people, it was spent in the comfort of their own homes. Now, consider spending a 6 to 9 month journey to Mars to find yourself over 225 million kilometers away from home, all topped off with the knowledge that your fate is uncertain and that rapid rescue is not an option. So we must be extremely selective on who gets sent to the red planet. In short, candidates must demonstrate exceptional fitness and resilience to psychological symptoms of severe isolation and high-stress situations. Moreover, candidates must be proficient in medicine, engineering, robotics to ensure self-sufficiency on Mars. To fill all the roles, the European Space Agency and NASA are planning for 4 and 6 explorers respectively. The crew must not only be able to tolerate each other, but also be proven to work effectively before getting sent into orbit.
We must also consider the ethical implication of Mars's colonization, which extend far beyond the technical challenges, and they touch on the fundamental questions of human responsibility. A primary concern involves planetary protection. Mars hosts an untouched environment that could harbor unique life forms, and introducing even accidentally Earth-based organisms risks irreversibly altering this ecosystem. This presents a dual challenge, preventing forward contamination of the Martian environments and the back contamination of Martian organisms on Earth. While current planetary protection protocols exist, enforcing them across an entire planet presents unprecedented challenges. Additionally, there's the question of resource management on Mars. While Mars could harbor valuable resources like metal or water, their exploitation raises questions about ownership and governance. The Outer Space Treaty of 1967, ratified by 102 countries, establishes that the space exploration shall be carried out for the benefits and in the interests of all countries and shall be the province of all mankind. However, this document creates ambiguity regarding private enterprise activity. The treaty fails to provide specific guidelines for commercial resource exploitation. This becomes particularly relevant as private companies like SpaceX develop capabilities for Mars exploration. Critical questions emerge. If we discover valuable resources on Mars, who has the right to exploit them? Would Earth-based governments claim oversight of these resources? Would a finders keepers approach lead to the same resource inequalities we face on Earth? Without robust international guidelines, Mars risks revolving into an unregulated commercial enterprise. Let's take a small step back on Earth. The pursuit of Mars's colonization raises profound questions about resource allocation and societal priorities in an era of pressing global challenges. The astronomical costs associated with Mars exploration, which is estimated in the hundreds of billions of dollars, prompt legitimate debates about the allocation of humanity's financial and intellectual resources. While Earth grapples with urgent issues like climate change, poverty, and healthcare access, significant investments by governmental entities in Mars missions might appear questionable to some. This opens the door to private companies like SpaceX and Mars One, introducing both opportunities and complications. Their profit-driven motives raises concerns about prioritizing commercial interests over scientific discovery and humanitarian benefits. Mars One's business model, which proposed to fund the Mars mission through reality TV revenues and the broadcasting rights of the mission, exemplifies these tensions. While it did generate public interest in Mars exploration, it also highlighted potential conflicts between entertainment and scientific rigor and ethical considerations. The challenge lies in finding a balance between leveraging private sector capabilities while ensuring that Mars exploration serves humanity's broader interests, rather than merely commercial objectives. It is also worth noting that Mars One declared bankruptcy back in 2019, highlighting the difficulty of undertaking such projects. Looking towards the future, technological advancements in propulsion systems have the potential of cutting journeys that were 6 to 8 months down to just a few months. Such improvements could transform Mars from a distant destination into a more accessible frontier sooner than we may think. However, we must remain mindful of our responsibilities as interplanetary explorers. Mars represents more than just another world to explore. It stands as a test case for humanity's ability to expand thoughtfully and ethically beyond Earth. The success of Mars's exploration will be measured not just by our ability to reach and survive on the planet, but how we balance scientific discovery, environmental preservation, commercial interests, and humanitarian benefits. Our approach to Mars will set precedents for future space exploration and potentially shape the course of human civilization. Our decisions today will echo through generations, determining whether Mars becomes a symbol of human achievement or another story of failed colonialism.